All right, so after some computation, that the error is bounded by this number. Okay? So now you can imagine if I use more power here, like x cubed, maybe x to the 5, x to the 7, you will see that this error will be smaller, getting smaller and smaller. Okay? So the sine x can be approximated by this with understanding that the error is no more than this. Okay? Now, this concept is very, very important in the application. The first application is the most important application is your calculator. Okay? So if you have a calculator, right? I'm sure you all have, looks like you all have a calculator. So suppose I give you sine of, say, 0.45. You plug in, right? Immediately they give you a number. I don't know what that number is. How did the computer know that? How did the computer know this? I mean, if you open the calculator, you cannot see, there's no cheat sheet there. Okay? How did the computer know this? I mean, you can, you go, okay, maybe you say, oh, how about this? How about 003? And you key in this, they give you a number right away. How do they know that? They don't memorize this, okay? They don't memorize. There's no table there because why? Because there are tens of millions of people using calculator every day, and everyone must have different questions, different problems. So it's just impossible to have a table. So how did the computer know that? Well, we have to give thanks to Taylor polynomial. So for example, I want to find what this is. So what did the computer do? Computer immediately compute x minus 6x cubed and provide even more, okay? Maybe 5, so maybe, okay, so 5 factorial. Maybe they compute more. It just depends. Okay, maybe compute more. And then they compute this. Actually, they compute. When we key in this, the computer actually doing this computation. This is what computer is doing. This is what he is doing. This is what he is doing. And this is very convenient for a computer. Why? Because all the terms are, if you look carefully, they are addition, subtraction, multiplication, and division. These 4 operations is really what a calculator or what a computer can do. I mean, even though it's a supercomputer, but it's actually doing all those 4 things: addition, subtraction, multiplication, and division. That's all what it's doing. And because the computer, the speed of the electron is the speed of light, so it's very fast. You just key in this. You key in this, then the computer will calculate this. But because their speed is so fast, so they give you answer right away. Now, the calculator, if you have a scientific calculator, then it has those, right? If you open it, you will see a lot of this kind of gate, that kind of gate, just something like this. A lot of these kind of things. This is the wiring of this. So, for example, if I ask for sine then they actually hold this gap, this design, they compute this. Now if I cosine, then the formula is different for cosine. Then they call that different design, okay, different design. And this they switch it very fast. So that's why if you look at calculator, a scientific calculator, you have e to the x, you have e to the x, right? You have natural log of x, all this. All these are really wild in the calculator. And sometimes you probably can get a calculator like for free at the drugstore. Now that kind of calculator is free. Normally it's not a scientific one. Because for a scientific one they have to wire it, so it becomes expensive. But if it is a free one, normally they don't have this. Because they don't need to wire it. Okay? Alright, so this chapter 9 is very important in application. Alright, let me see, we have, what time it is now? Okay, let me see if we can do one more problem here. 50. The problem here is all the same. So how about let's look at 65, natural log of x. Okay? 65. Alright, I have natural log of 1 plus x. They want us to approximate by x minus x. Copy this right. Sometimes it's so difficult to read. X squared over 2. And they give us the interval minus 0.2, 0.2. Okay? Alright, so first, okay, again they want us to find the error, boundary for the error. So I need to decide what n I have done here. N is 2. Okay. N is 2. So error will be R. Yes, yeah, 2. If the polynomial is 2, then it's R2 in this one. Okay? So R2 of x is equal to 2, right? 2 plus 3 factorial. S3. C, A is 0. Again, A is 0 here. Because there's no A, so A is 0. X to the 3. So that's an error. I need to bound this. Okay? So let me compute what this guy is. So f of x is natural log of 1 plus x. What's f prime of x? 1 over 1 plus x, right? What's f double prime of x? Minus 1. What is f triple prime of x? That's what they want, triple prime. That's equal to 2, 1 plus x minus f plus this is f triple prime. So R2 x, I only bound this one. Okay, 3 factorial. And the c, right, c, so 2 over 1 plus c to the 3. Okay, 1 plus c to the 3. And the x to the 3, so it's actually value. Okay, so this is equal to 2, that's 6, right? 3. Absolute value. Alright, so what's my c? I know that c is between minus 0.2 to 0.2, right? Okay, now c is in the denominator. So the smaller c is, the larger the fraction is, because c is in the denominator. So, okay, so this is bounded by, I'm going to just substitute c by 0. okay, because c is the denominator. Wait a moment, and this may be wrong, because c no, yeah, should be this, because c can be negative, so actually this will be bounded by negative 0.8, 0.2, I mean. Yeah, so if c is very small, the smaller the c is, the larger the fraction is. So this is 1 minus 0.2 cube, okay? And times x. X is also here, everywhere is, so everywhere is 0.2 cube. Okay, they're bounded by this. And this is 2, 6 times 0.8 cube, right? Times 0.2 cube. What's this? Okay, so again, I just have to use my calculator.